For this session, we'll be having the solutions to nth order non-homogeneous linear ordinary differential equations. So last time, what we had were the homogeneous solutions. For this time, we'll be solving the non-homogeneous. And for this one, we have two methods. The first method is what you call the method of undetermined coefficients. The second method is the variation of parameters. For this lecture, we'll be focusing on the method of undetermined coefficients. We have here the nth order linear ordinary differential equations with constant coefficients. This is the standard form, is equal to Rx. Last time, what we had were Rx is equal to 0. That's the type 1 or the homogeneous type. Now we'll be having the Rx is non-zero, where it is type 2 or the non-homogeneous type. Again, we have this standard form. And then this is with the differential operators. For non-homogeneous linear differential equations, what we will be having as a general solution is y is equal to yc plus yp. Yc is what you call the complementary function, which is the general solution of the homogeneous linear differential equation. So how do we solve that? Similar to how we solved last time, the differential equation is equated to 0. So we have the auxiliary equation equated to 0. So either you have any of the four forms. The first form, we have here the ones with real and distinct roots. The second one, we have the real and repeated roots. The third one, you have the complex but distinct roots. And then the last one, complex and repeated roots. So C1, C2, up to C and so on are all arbitrary constants. And as I said, you have the plus YP. The YP is what you call the particular solution of the original differential equation. So again, we'll be doing the method of undetermined coefficients. Let's have that. For the method of undetermined coefficients, or MUC, take note that Rx itself is a solution of the homogeneous linear ODE with constant coefficients, and hence the roots can be determined from the given Rx. I want you to take note of this one. This is important. The Rx can be polynomial, exponential, sine, or cosine. So only those four. Again, polynomial, exponential, sine, and cosine. So how do we solve? To solve the non-homogeneous linear differential equation, we must do the following things. So these two. Number one, find the complementary function yc, which is again the general solution of the differential equation equated to 0, and find any particular solution yp of the non-homogeneous equation, so the solution of the Rx. So you separate the equation into two. The left-hand side, you try equating that to 0 to get the general solution, or the yc. And then the right-hand side, Rx, you try to propose a particular solution for that. So these are some examples. What I want to show you here is that this one is polynomial in form. This one is exponential in form. This is a combination of polynomial and cosine, exponential and exponential, cosine, exponential, polynomial, and cosine. So all these can be solved by the method of undetermined coefficients. So some of you might ask, what if the right-hand side is not equal to any of those four functions? That means you cannot solve it using the method of undetermined coefficients. We should try another method. So let's try. So it says there that the first step that we should do is solve for the yc. One, solve for the yc when f of m is equated to 0. So that means we have to solve for the f of m. In here, you remember that this one is basically third order derivative of y is equal to 12, and then you change it to m. But then you want to equate that to 0. to solve for the homogeneous part. So I can say here that m is actually 0 3 times. So can you solve for the complementary solution for this one? You can say c1 e to the 0x plus c2 x e to the 0x plus c3 x squared e to the 0x. Or if you don't want to write e to the 0, you can just say c1 plus c2x plus c3 x squared. Those are the constant coefficients. So let's just put a star on this because we'll be using this later on. Now, according to the steps there, step 2 says we propose a YP based on R of X. So you have to say that what is the R of X? R of X is actually equal to 12. In here, if I ask you, in order to get this, what should be the root of the auxiliary equation in order to get this? Can I safely say here that since it does not contain an E, that M is equal to 0? But then you have to take notice here that M equals 0 already appeared 3 times. So that means if I would equate this to 12 and then say that the 12 there does not contain any exponential functions, so that means M is equal to 0, that means the M equals 0 here is actually the 4th time M equals 0 has appeared. Therefore, you can safely say here that if it's the 4th time, you can propose YP is equal to C4, but then since it's the 4th time, x cubed e to the 0x, or if we want to remove the e to the 0x because m equals 0 anyway, I can just say C4 x to the 3rd power is equal to your YP. Let's go to the 3rd step. According to the 3rd step, what we do is let's go back to the original equation using the y of p. In the original equation, you can see there that it is y triple prime is equal to 12. But instead of just y, I'll use y of p. So that means based from step number 2, I can have a y prime of p, y double prime of p, and y triple prime of p. The y prime of p in here is basically 3 c4x squared. In here, it's 6 c4x. In here, it's just 6 c4. So that means if I would plug this in number 3, I'd be getting 6 c4 is equal to 12. So that means I can already solve for c4. My c4 is simply 2. So now that I have this, I can have my step number 4. What is step number 4? Step number 4 is basically y is equal to the complementary and the particular solution. So I can say that y is equal to yc, which is c1, c2, x plus c3, x squared, and then this is 2. So I'll just use 2 and then the yp because that's c4. 2x to the 3rd power. This would be the answer. Let's try another example here. So let's do step number 1. Step number 1, again, solve for yc by setting the auxiliary equation equal to 0. So that means if I were to plug everything in, this becomes m squared minus 3m minus 4, and then equate that to 0, solving for the homogeneous portion first. Factoring this out, that means the roots that I have are -1 and +4. For these roots, I can say that my complementary solution would be c1 e to the -x plus c2 e to the 4x. And then I'll put a star here because I'll be using this later on. Okay, let's go to step number 2. Step number 2, solving for Rx equals 3 e to the negative 2x. We would want to solve for the yp. We will propose a solution for yp. Now, in order for us to get this, guys, what should be the root, guys? In order to get an e to the negative 2x, that means I should have a root that is negative 2, right? So I'll propose a solution. So that means the proposed yp would be any c. So let's just use c3, e to the negative 2x. All right, we don't have a problem with this because that came from the negative 2 there. Now, looking at the original problem is second derivative minus the first derivative minus 4. Y is equal to 3 e to the negative 2x. And as I said, instead of just y, you will put a yp. That means we need a second derivative and a first derivative. So if your yp is equal to c3 e to the negative 2x, that means the y prime of p is negative 2 c3 e to the negative 2x, and then the y double prime of p should be 4 c3 e to the negative 2x. And then, as I said, using the original, substitute the yp's that you were able to solve for. Second derivative, that means it is 4 c3 e to the negative 2x minus 3. The first derivative is negative 2 c3 e to the negative 2x minus 4yp. So minus 4 c3 e to the negative 2x is equal to 3 e to the negative 2x. All right? And then what we do here is we try factoring out the e to the negative 2x. So let's just say c3 e to the negative 2x. Let's factor it. So you'll get 4 plus 6 minus 4 is equal to 3 e to the negative 2x. All right. So going back here, I have here 4 minus 4, so it's 6 c3 e to the negative 2x is equal to 3 e to the negative 2x. Therefore, c3 is 1/2. So with that, let's go to step number 4. Y is equal to yc plus yp. Therefore, y, going back, yc is just equal to this. c1 e to the negative x plus c2 e to the 4x plus the yp here is this one, c3 e to the negative 2x. Therefore, that's 1/2 e to the negative 2x. So this is your solution. So for this one, again, let's go to the first step where f of m is equated to 0. So let's solve for yc. So it becomes m squared plus 2m minus 3 equals 0. And then let's factor this out. So for these two roots, you can give the complementary solution. So this one becomes c1 e to the x plus c2 e to the negative 3x. Let's go to the second part. Your rx, which is 2 e to the x plus 4e, the 3x, to solve for your yp. We will be proposing a yp. Now, with this, guys, what is the m? 1 and 3. However, you notice on top that 1 already appeared. So that means this is the second time that 1 has appeared because there's already a 1 on top. So with this, what is your recommended or proposed y? It becomes c3, and then since it's the second time it appeared, x to the x plus c4 e to the 3x. The third part. So original equation in terms of yp. But then, look at this. You have the second derivative. That's the highest. So if you have your yp as c3 x e to the x plus c4 e to the 3x. What is y prime of? You have two variables, so copy the first, derivative of the second, plus copy the second, derivative of the first. It's just this. And then 3c4 e to the 3x. However, we won't stop here because we have, or we need a y double prime. So again, copy the first derivative of the second, plus copy the second derivative of the first, plus in here, it's just the same. In here, it's 9c4 e to the 3x. So we can combine these two to form 2c3 e to the x. We don't have a problem with that. Now let's plug it in the original equation. So that means this one is c3x e to the x plus 2c3 e to the x plus 9c4 e to the 3x plus 2 times derivative. So that is c3 x e to the x plus c3 e to the x plus 3 c4 e to the 3x, and then minus 3 times the original, which is c3 x e to the x plus c4 e to the 3x is equal to 2 e to the x plus 4 e to the 3x. Let's equate those with x e to the x, equating coefficients. So you have c3 plus 2c3 minus 3c3 is equal to, there's nothing. So that means 0 equals 0. Now, let's equate those with e to the x. 2c3 plus 2c3 is equal to 2. So I can say that 4c3 is 2. c3 is equal to 1/2. No problem with that. Let's equate those with e raised to 3x. c4 is equal to 4. I can see that c4 is equal to 1/3. Step number 4, y equals yc plus yp. Therefore, the final answer would be c1 e to the x plus c2 e to the negative 3x, and then the yp starts with this, c3. So plus 1/2 x e to the x, and then c4 is 1/3. So plus 1/3 e to 3x. As I said earlier, after the first one is the easy part. This is the one that we have studied before. Now, the second portion is proposing a YP, or the particular solution. You basically want to propose the form. Where do you obtain the form from? From the Rx. So we write the Rx down here. 2 e to the x plus 4 e to the 3x. Now, what are the roots for us to obtain these? The root for this one is m equals 1. The root for this one is m equals 3. The problem is, whenever we get the roots, we have to look back up. Are there any similar roots on top? Yes, there's one there, there's one here. That means the one here is appearing the second time already. Constant times its second time around, so it's times x, e to the x, plus another constant, e to the 3x. It just so happened that we have already used C1 and C2, so we'll be using C3 and C4 now in your proposed YP. Can you follow?
Yes, sir. Yes, po. Thank you so much.
All right. So basically in here, just a recap. Look at the original equation, but then we plug in the YP. This is the original equation in here, but then that's just letter Y. Since we proposed a YP, we equate that using the YPs. So since this is a second derivative, you'll plug in the whole second derivative in here. And then that's 2 times the first derivative. So 2 times this one. That's why I place a 2 in front. 3 times y, it's 3 times the yp instead, which is this one, equals the answer. The purpose of this one is to be able to solve for the constants for the particular solution. Now let's try this one. This one might be a bit longer. So step number 1, we would want to solve for yc. How? By equating fm equals 0. So we'll get the auxiliary equation. So that one, m squared minus 3m minus 4 equals 0, right? So m minus 4 and m plus 1 equals 0. Therefore, you'll get either 4 or negative 1. So for this, you can already obtain your yc. Your yc is c1 e to the 4x plus c2 e to the negative x. No problem with this. Let's put a star because we'll be needing this later on. Now, step number 2. Propose yp. Where do we get this from? Rx is equal to 16x minus 50 cosine of 2x. All right. So with this Rx, what should be the roots, guys, for us to get 16x? Take note, it does not have an e. That means what? 0, you're correct. So, but then it has an x, so that means it's 0 and 0. So 0 appearing twice already, because remember, whenever it has an x, it means it has repeated already. If it has an x squared, that means it appeared 3 times already. Look at this. When do we get a cosine or a sine? Whenever we have. So you have to have a complex root. Meaning in here, your a should have been 0. Your b should have been 2. That means your root would be 0 plus and minus 2i. Therefore, for that one, let's propose a yp. What's your yp, guys? C3 e to the 0x plus C4x e to the 0x plus C5 e to the 0x cosine 2x, C6 e to the 0x sine 2x. So let's fix this. I can just say this is C3, C4x, C5 cosine of 2x, C6 sine of 2x, because that's e to the 0x anyway. No problem with that. Now, step number 3. So we have here, proposed yp is C3, C4x plus C5 cosine of 2x plus C6 sine of 2x. So basing it from the given problem on the top right, you know that we need a second order derivative. So based from this, let's solve for y prime. Y prime would then be C4 minus 2 C5 sine 2x plus 2 C6 cosine of 2x. And then the y double prime is negative 4C5 cosine of 2x minus 4C6 sine of 2x. So we'll go to step number 3. Original equation, but then use yp. So the original equation using yp, y double prime is negative 4 C5 cosine of 2x minus 4 C6 sine of 2x minus 3 times y prime. So C4 minus 2 C5 sine of 2x plus 2 C6 cosine of 2x, and then minus 4y. So minus 4 times, what's the y? It's C3 plus C4x plus C5 cosine of 2x plus C6 sine of 2x is equal to 16x minus 50 cosine of 2x. So there's quite a lot. So what I would do here is equate coefficients again. So let's try those with cosine of 2x. Let's just fix this. I can see that this one is 8c5 plus 6c6 is positive 50. So for the sine, so that means 6c5 minus 8c6 is 0. What else do I have? I have those with x and those with constants. For those with x, on the left here, so I can see that C4 is minus 4. I was able to solve it. For the numbers, C4 is negative 4 times negative 3 is positive 12. If I move it to the other side, negative 12 divided by 4, I can see that C3 is 3.
You can just separate the different types of x's and then
Yeah, so basically, you're equating just the coefficients to solve for the constants. You understand? So for this, let's simplify. Maybe we can still simplify. 4c5 plus 3c6, I divided it by 2. And then the other one is 3c5 minus 4c6 is equal to 0. So I divided it by 2. So now, what do you want to cancel? It's up to you. So let's just say if I were to cancel c6, I'll just multiply this by 4. I'll multiply this by 3. I'll end up having 16c5 plus 12c6 is equal to 100. In here, that's 9c5 minus 12c6 is 0. So I'll end up having 25c5 is 100. Therefore, c5 is equal to 4. If c5 is equal to 4, c6 is equal to 3. Am I correct, guys? I divided it by 2 first.
okay, thank you.
And then times 4 times 3. Based from step 3, C3, C4, C5, and C6. What are your answers? What's C3? 3. C4 is negative 4. C5 is 4. C6 is 3. All right. Step number 4. Y is equal to the complementary plus the particular solution. Therefore, the final answer would, let's look at the complementary with the star. C1 e to the 4x plus C2 e to the negative x. And then there's the particular solution at the bottom. Plus 3 minus 4x plus 4 cosine of 2x plus 3 sine of 2x. That is your solution.